of significance is the level of trust, or the interval of trust. So to what extent can we trust these findings? On the level of 0.01 or the level of 0.05? And we have many levels of trust. And actually the number 0.01 is a percentage, which is 1%, and 0.05 is another percentage, which is 5%. So on 100 tries and attempts of your study, you can trust it like 95 times, and only 5 times can be wrong, and so on. So this is the concern of statisticians, not our concern. Just do, like me, accept them as they are. I do understand the concept of statistical significance, but I don't understand how is it calculated or measured or even considered. I just assume it as it is. Level of significance is the level on which I can trust the validity of my data. Okay, so this is it. Let's move to the next slide. All right, so what are we going to use the degree of freedom and level of significance for? We are going to use them to find the tabulated value. I already said in the first slide that to read the value or to test the hypothesis, the value of t, and test the hypothesis, you need to compare it to a tabulated value. Here is the table, or the place where you can find the tabulated value. Tabulated means put in a table. As you can see here, many values, many numbers. Okay, so all the values provided here are the values of t, but the values of t, if you can see above, in many levels of significance. So level of significance for directional t. So these are different values of t, tabulated t, in different levels of significance and different degrees of freedom. Here the vertical column, okay, df on the left, df 1, 2, 3, 4, 5, 15 and up to 64. So we have degree of freedom and level of significance. For each level of significance and a degree, specific degree of freedom, there is a tabulated value. See now, the tabulated, it's tabulated by statisticians. They did their own calculations. I don't know what they did exactly, yet they provided us with this table. These tables are found everywhere, and there are a lot of tables like these, longer tables. Of course, I summarized the table to fit my slide. You can see it's cut. Okay, I cut values from 15 up to 63 because I cannot involve them here, and there are tables that include thousands of values. Okay, nice. Let us check now our values. We said that we're going to work with alpha 0.05 and alpha 0.01. As you know, and as I said, we have many other levels of alpha on the same line. Alpha equals 0.1, alpha equals 0.05, and alpha equals 0.025, and so on. Okay, and of course in social sciences we adopted two values, the 0.05 and 0.01, because they serve us, given the nature of our study, because we are not that exact and we cannot have exact trust and exact statistical significance, unlike other sciences that can be so exact and there is no way for mistake, because the statistical significance is somehow the interval of mistakes you can make. So from like alpha 0.01, I said alpha that equals 0.01 is a percentage, that means 1%. So out of 100 tries and attempts of your study, 1 is going to be a mistake, or 1 is not going to be statistically significant, or you cannot trust 1 attempt, and the 99 attempts are right. This is my own understanding of this idea. Okay, so this is mathematical, this is statistics. I want you to care about the levels, so do not think it over, just take it as it is. I am working on social sciences, so I have two levels of significance that serve me, as 0.05 and 0.01. Now, what about the DF? Just go to the DF. Here's the DF in a green circle, And the DF in our activity is 64. The DF can take different values starting from 1, as I said, and up to thousands. Okay, here depends on the sample you are using. As you know, we use the sample to calculate the DF. So let's say if my sample was not 33, I would not have the sample of 64. Let's say if my sample is 100, and we do the same steps to calculate the degree of freedom, of course my DF would never be 64. It would be like, I don't know, 100 or 120 or less. Okay, so now what are we going to do? The next step is looking for the value of t on the table that goes with the alpha and the degree of freedom. Alpha 0.05 and TF 64. Yes, it's 1.79, 1.7, okay, or 1.7960. Let's find the other value of t, or tabulated value. Okay, perfect. It's 2.70180. So, and the level of significance alpha 0.05 and the degree of freedom 64, the tabulated value is 1.79. So the calculated value is not the calculated by statisticians. It must be 1.79. And in the level of alpha 0.01, the tabulated value, or the one calculated by statisticians, is 2.71. So after finding these two values, it's time to compare between them and the value you found. If you still remember, the value we found is 4. Okay, here at the level of significance alpha equals 0.01 and the degree of freedom 64, the tabulated t is 2.71. Okay, this is what we have found on the table. As you can remember, the calculated value, you can go back in the video and check the calculated value. The calculated value of t in our example was 4.41, I suppose 0.41 or 47. So the t calculated is more than the t tabulated. 4 is more than 2. And then we can say here that there is a statistical significance. So the condition is, if t calculated is more than the t tabulated, there is a statistical significance. As I said earlier, if there is a statistical significance, it means that H0 is rejected and H1 is accepted. At the level of significance alpha 0.05, degree of freedom 64 and t tabulated was found to be 1.79. The t calculated again here is more than the t tabulated, or the t tabulated is less than the calculated. There is a statistical significance, and H0 is rejected and automatically H1 is accepted. Let's go above. H0 says or states that there is no statistically significant difference between males and females performance, and this hypothesis is rejected in our study. Here we can say that there is no statistical difference, they are equal, they are similar, and automatically the accepted hypothesis is the alternative one, which says there is a statistically significant difference between males and females. And voila, this is what you did, and this is how to test the hypothesis. I don't think this is a rocket science or something very, very difficult to conduct. All you need to do is calculate t and then go look for the alpha and the df to help you find the tabulated t, and then compare it to the calculated one you had. So if your calculated value is more than the tabulated value, you can say that there is a statistical significance. And if there is a statistical significance, this means that your H0 is rejected. And you can do the same on the other level of significance, let's say alpha 0.05, and check whether there is statistical significance or not. And of course, the opposite means that you accept H0. Let's say if t tabulated is more than the t calculated. If the t tabulated is more than the t calculated here, you can say that there is no statistical significance, and the H0 is accepted. See, this is something we're going to see in this.